Yeah, so I'm gonna hand it to Monika. So Monika has been doing this, like I said, for what 14, 15 sessions, and she's an iOS developer for over 8 years, and she's worked in different kinds of teams, ranging from being the sole iOS developer in a company to a group of 10 to 12 iOS devs. She enjoys taking an idea from rough inception to final product deployment. And she still loves coding after so many years and is thankful about that. So it's all yours now.
Great, thank you. Let me share my screen. I just realized that I switched laptops and I had my highlights in the other document. I have it in both, but it's fine. So we're going to go over chapter 15, where we see the usage of async await in SwiftUI. And the first thing is that, just like Combine, Apple has upgraded some of its APIs to support async and await. And one that is not a surprise is actually the URL session. Just like in Combine, there was a publisher for URL session, and you could subscribe to that. The call for basically retrieving data. So this shared data. Now there's you can basically call await in front of it, and then it will return. Returning the data and response. And that's really nice because, as you guys remember, with the other, the more traditional way, you call this and then you get a call back. And in the callback, you do all your checks. So again, in the spirit of how async and await is trying to make the code much clearer, and then have the API call actually return stuff, even though it's asynchronous. So it's kind of a nice way to do this. And basically, there's an example where we're searching for a search term, and Peter is actually using, there's like a words API. So he's basically getting the search term, creating his request. And the main thing to kind of pay attention to that, instead of, again, doing a whole closure and callback, he just, sets like the tuple data and response to equal what he's fetching from URL session. And the big thing is, we need to put this await in front of it, because it's something that, will only come back when the data and the response is retrieved. Of course, there could be an error, but you're basically, this goes into a thread pool, and we'll talk about it a little later. And when it's, when the data is ready, you sort of kind of come back from that, and then you can do the rest of the code. And he's checking to make sure this is like a URL response, and you have a status code 200. If you don't, then, he throws an error, and then he's kind of decoding the word from the JSON that he gets from the data and returns the word. And you notice that there is this try and catch, because while, you're doing a URL session, there could be a networking error, and you could basically not be able to successfully even call this. And that's why it's a good practice to have this try and catch here for this specific call. And it was interesting that, basically, he's saying that, we have this asynchronous call. And basically, we create this, suspension point. So that's kind of what he's emphasizing. And when the function is suspended, it's kind of interesting, like it's just kind of paused in a sense. The runtime, if we were, for instance, doing this in the main thread, your runtime can use the main thread to do other stuff that's happening in the code. And when the result is in, when the operation's done, then, you get a chance to kind of come back, the code to come back and finish the rest of the code that's following that particular async call. And it's a little weird thing to see, oh, does that really work? But, it does work. And he gives an example that, you're calling a call center agent and you're put on hold, right? So you don't disconnect your call, but because it's on hold, you can go and, drink coffee, brush your hair, talk to someone else. And then suddenly you hear the call center agent, hello, I have, what you were looking for, and you're back to where, what you were trying to do. And it's just that, basically iOS is providing this functionality for you. So it kind of manages the whole thread pool, putting this request in the thread pool and sort of dealing with kind of suspending that call until there's results. One important thing is that, to call an asynchronous code, you need to be in an asynchronous context. If you just kind of like, if you just had done this, then you would get a compiler error if you didn't have this task, because you're sort of in a synchronous call where each call is, we're kind of waiting to get the result of the function or whatever it's doing. And in here, this is a asynchronous call. So you have to we had to either put a await here to say that we were waiting for the result of this thing, or, you're basically putting this task sort of annotation. It's not quite an annotation, but basically putting this in this context so that the compiler knows, oh, okay, so this is going to happen asynchronously, and at some point there will be a result. And you can have other code inside of here, but again, it will be kind of paused, so nothing else will happen after that until this is done. And there are now in SwiftUI support for this kind of like asynchronous calls for some of the things that would make sense to do asynchronously. For instance, when a view appears, you could have a .task view modifier, and we'll check that, which basically, that .task gets called when the view has appeared, and, it's going to run some code, and the results, once there are results, then the UI view is going to be updated. And then also there's like a refreshable, and we'll see that. So if you have a list view, and usually, even with the table view in the UI kit, there was a way you could have a refresh view where if you kind of pull it, pull the table, then, it would go and try to fetch new data. And with SwiftUI, that becomes really easy because we can just specify this refreshable modifier and then put whatever code that's asynchronous that's going to go run. And once the results come, you can see the results. So let's first look at the task view modifier. So if we were so let's say that you had an unappear view modifier, which we get whenever we have, things that we need to call once the view is appeared. Now, if we just go and put, await view model execute query, because this execute query is asynchronous, it's going to complain, even though we're putting this await thing, saying, well, this is supposed to be like synchronous context, and you're basically doing an asynchronous call here. And so basically, one way to take care of that compiler error is, again, to put this task thing, which basically kind of tells the compiler, okay, this is going to happen asynchronously. And I was incorrect before. I thought if you could just put await, you didn't have to put this, but that's not correct. Like, you need the await anyways, because, it's again saying that, you're waiting for the results of this, but it's still an asynchronous call. So on top of it, you need to put this in this task context. And, it is a little verbose. So SwiftUI now, like, because we can have all these cool view modifiers, there is a new view modifier that just is .task, So if you put that, basically knows that at the time that this view is appearing, then it's going to go and call this asynchronous task. And so you don't have to go put on appear and then task. You could just do .task, which is kind of like a shortcut. So that's, they probably looked and said, this is going to be a very common thing that people are going to do, which makes sense. Imagine in the old, UI kit with your view controller, you always had, view did load, and then you would call some, network call and then update, your table view or whatever. In this case, it's basically a similar thing. Once the view is loaded, go and call this, and then, kind of wait for the results. So let's see. And another one is, remember how we had like a task context? You could also have, similar to that, an async context. So you could use that. So let's say we have a refresh button where we want to refresh the view model. We can put this again to say, that this is an asynchronous call. And basically at the time that, you press on refresh, it's going to go and call the view models refresh. And then what I was mentioning about that refreshable view model. So there's a lot of times where, we want to refresh the view. So instead of like, if it's this whole pull to refresh thing where we don't have a button, like how we're doing it here, but we were doing the whole pull to refresh. Now there's a nice, convenient view modifier that you just put .refreshable, and then it's kind of, yes, Nilesh.
I think that async is a replacement, like task is a replacement of async, the above part.
Oh,
Yeah, this one.
Oh, okay.
Yeah.
This means we need to
Yeah,
use task to create. Okay, here's an example that initiates. So you're saying we would actually put task here.
Yeah,
Or
so
we need
basically
that
when async await was in beta for Xcode 13, that time we used to use async, but when they
Got
released
it.
with task, they updated it with task.
Okay, got it. I kind of missed that. Yeah. So really in the new like updated way, and I don't even know, I have to kind of look, there were some changes in iOS 17 too, but it would be task here, you're saying.
Yes.
Cool. Thank you for letting me know. And then with this refreshable, you don't have to put the task because it just inferred that you can call an asynchronous call in there, right? And so then he was given an example of like, you have this view model, just like before we have our observable object. And this actually has changed a little bit with iOS 17 in terms of, I think now we just say it's observable and we don't do published, but let's not worry about that. But in the current way of, making sure that updates to certain properties of your view model can be kind of subscribed to. And if there's a change in there, whatever it's, observing these published properties, then they can get the updates. And he's, so here we have like search text and tips, and these are all published. And I think in the example, basically, I think it was here that, where was it? I was trying to show that search text is something that the user types, and as they're typing, obviously we're getting the updated, characters, and that is, oh yeah, now I'm remembering. So another sort of cool view modifier is this whole searchable thing. I think here, yeah. So let's say, kind of in UI kits, we used to have that whole search controller that we added to the navigation item. And that's how we could get that search field, and you could type things. And of course, it was more tedious because you had to create the whole delegates for the text field and get updates when things were being typed in. In the combined SwiftUI world, then, if we say there's a searchable and this view model, well, whatever, it's some bindable variable here, as the user is typing those characters, we actually could basically get the updates kind of the way we did previously with Combine. And here, like, so we're combining two things, because one is like the search text. And then one is like, we had these tips that are like, just an array of fixed tips. Now, as you're getting the update to the search text, you can check to see if this whatever you've typed in your search is available in the what is it, in the items, which is like, these tips that we had set. And if it's matching one of them, then you're basically updating your filter tips to show. So it's kind of like, you have any sort of a pattern where you're doing that kind of auto completion thing. So you have like some possible results for your auto completion. And as the user is typing in the search text, you can check if there's a match between those auto completion results and what they are typing in. And then you can show that list of potential matches. So the user and it's kind of like a convenience for the user to see, oh, okay, I actually did, instead of typing in the entire thing, as long as it contains that current search text, then you can give these potential auto-completed terms. And that's in here done, using Combine. And he's doing it for both tips and favorites, because, it could be some current favorite, we have this list of favorites. One of them could match what the user is typing. For the tips, the same kind of thing. And that updates your filtered tips and your filtered favorites. And this is all in the view model. And then here, is the actual view where, he's showing like, here's his, all the tips, here's all the favorites, and, what you get to see, is filtered by what the user is typing in. And currently, it's just a local filtering that's happening. So we're not doing any sort of async right away because we're not hitting the network or anything. We're just using Combine. And as the user is typing in this, we're trying to match with that and update the result. Does this part make sense? Did anyone actually run the sample app to see this? So that might be a good thing after this, if you try it, because it's an interesting way to show how you can use Combine, locally to be updating, sort of integrating local search with some auto completion of values that you have. I mean, sometimes auto completion shows, you're typing and then you get a list of potential terms. In here, all he's doing is just updating the matched tips and favorites based on what you're typing in for search. But there are cases where it's not necessarily like you search something, you type something, and then you want it to go, you're going to take that search term and go to some backend, some server, and actually search for that term and get the results. And in this case, you would only want to search once the user hits the enter key. And so you not only need like to have that searchable thing, which kind of renders the whole search view and sort of like what you pass in for the search term, but then you also have an unsubmit, which is, and this of.search is that this is a submit for what you're searching, which is interesting to know, because you could have, remember with unsubmit, you could have different form and have an unsubmit there that then renders the whole submit button. But in this case, because it's for the search, it's basically going to be, that search button is going to be sort of synced or be connected with the search text field or part of the search text field. So you have a search field, and then in the bottom you have a submit button. And that could get triggered either by hitting the search button or hitting the enter key. And here's the cool part, that obviously when we hit search, this execute query, which kind of goes to the backend, and we saw the code before, which kind of hits that words API and tries to search for that and gets the results back. That, again, we have that task context, and we will be awaiting the results. And once we get the results, we'll see that we would be updating whatever was in the view, because there's once the search results happen, it's going to update other things for the view, and that will get updated. So any questions about this? And this is kind of a common operation that one would do. You can imagine that, a lot of times, you have some content that you want to make searchable, and, and that search has to, go and hit the server backend. So it's kind of asynchronous. And SwiftUI kind of gives you a nice way to not only render that search, but also provide a way to show the whole submit button and trigger the submit button. And then once the results of this it can update other views that are dependent. Well, it'll update other fields in the view model that are published, and there's going to be in the SwiftUI views that are, basically reacting to those changes in those fields and get updated. Now, this is something I think when I was playing around a little before, I did notice that Xcode does complain about like when you're sort of like do some asynchronous call and then you get a result. And then when you're like assigning whatever field you have to that result, then it shows you this kind of warning that says like publishing changes from background threads are not allowed. Make sure to publish values from the main thread. And the reason for this is that once, this field gets updated, the SwiftUI could be observing this field and that view gets updated. And the issue with that is that you want that whole updating of the view to happen in the main thread. And because, once this result comes out, you're not guaranteed that at the time that you sort of resume your operation, you're in the main thread anymore. So that is not guaranteed. So you have to do something specific to say, I needed that. It's kind of like in the old way with UIKit, you would have a callback from like a URL session, and that the actual networking call is happening in another thread, not in the main thread. And when it gets the results, that closure that you pass for the callback, that callback wasn't guaranteed to be in the main thread. So you had to make sure that in the callbacks code, if there were things you were doing, like updating some UI, that you had to do that dispatch async main to make sure that you're in the main thread. So it's a similar kind of issue with even this, even though you don't have a closure, but at the time that, the await is done and it gets a result, you're not guaranteed to be in the same thread where you actually called that async call. So, and then, he gives this example that, you have like fetch random word, and, you're, as we were looking at, you're doing your URL request and you're calling this await. And then here you get your word and you return it. And in the refresh, you notice that basically you're, awaiting this fetch random word and you're setting this. And the issue is that refresh is supposed to happen in the main thread. And when we get back this result, we may not be in the main thread. And he actually shows, like he puts these logging to kind of prove to you that, it's not guaranteed to be in the main thread. So, so he's putting here logs where it's calling is main thread before, is main thread after. And you can see that when the refresh was called before, the main thread was true, right? But after the refresh call, you see that the main thread is false. And that's kind of dangerous because if it's actually updating UI and doing all these things, you can possibly get a crash. So how do we ensure that we're in the main thread when we need to be. So let me show you an example. So this was when he was doing the printing, and he also does it with the debugger, which is kind of cool. I don't know if you guys have ever kind of put breakpoints in Xcode where you can see, like, so he puts a breakpoint before calling this refresh and a breakpoint after. And when he calls the first breakpoint, you can check and you see, let me sort of, you see how it says com apple main thread. So it was in the main thread at the time that it called that call. But then after it comes back, so now if we look, notice that now we're not in the main thread. So, we're in a different thread. And that's where things kind of get bad. And then, the compiler is complaining, kind of telling you that, you're basically not ensured to be in the main thread. So how do we make sure that, we do things in the main thread? And then he sort of goes over here. Yeah, and he just with the debugger, he's just again showing you how this is not in the right thread. So then there is this whole, there's a bunch of different ways, depending on the granularity of ensuring that when you do that asynchronous call that you get the result in the main thread. So there is like a main actor dot run, and there is like an open and close braces. And if you put the code in there, you're ensured that that's going to happen in the main thread. If a whole function, not just a part of, a segment of the code, if you want that entire function to be, because it's updating your UI to be in the main thread, then you can put this add main actor property wrapper. And if the whole entire, like your whole view model, you want to make sure that everything that it does, because it, it's has methods it's going to be used for updating the UI, then you can put the main actor property for the entire class. And, these are different strategies of, usually it makes sense to only put the part of the code that for sure we want it to be in the main thread. If other things doesn't matter, if we can return in a different thread, then, it may make sense not to make the entire class have the main actor, but a specific function, then it makes sense, because just doing a segment, with the main actor run might, and this is a good question actually to ask. Well, Mohammed might not have time next week to, but he had a whole course on async and await, and he kind of goes over when it makes sense to do these. But from what we saw, like here's examples, like, if refresh is something that, we want to make sure that's in the main thread, then the main actor property wrapper is put right in front of there. If the entire view model, if we just want, we don't want to we're adding new functions, and for each function we're determining if we need to do this main actor or not. And this specific view model is mainly used to update properties for the view, then it may make sense to put that main actor for the entire class. So it's just more efficient to do it for the main class, because anything that changes there is going to be reflected in the UI. So UI is going to update reacting to changes to this. So it may make sense that if it has any functions for updating, that they're all, and again, just so that it doesn't mean when it's like doing the fetch random word that's going to be in main thread. It's not. It's just that that suspension, when it comes out, whether it's going to be in a main thread or some other thread, is the distinction here. Any questions about that? Because I think this is a little confusing. So it's, don't think, oh, well, that's not very good. I'm calling like some never call and it's all going to be in the main thread. No, it's not. It's just that, you're sort of guaranteeing that at the time that you come back from any of these asynchronous calls, that the operating system puts you in the main thread. And let's see, and he just kind of summarizes all the things that we went through, that there's some convenient view modifiers, which is nice, so that it just makes, and again, the whole point is to make the code less verbose, to make it very clear, and you don't have to forget about things. So that if you do a .task, that's just going to be assumed to be an asynchronous call, and it's going to be triggered at the time that your view appears. And then a lot of convenience with this sort of searchable and refreshable, which is really nice, because in the UI kit world, it's actually kind of cumbersome to write. There's a lot of boiler code that you have to write to enable these things. And it's just so much more succinct and clearer in SwiftUI. Any other questions? So I would suggest that you actually go and run the code in chapter 15, just to see how that works, and kind of play around with it. That would be good. I'm actually going to do that too, because I went through very quickly, just looked at the code, but I didn't run it much, and I just read this chapter. But I think it would be good to do that. And let's see, anything else? And then next week, we're not going to get together because there's a different meeting, but the week after, we can then do this whole like final chapter where, he already given this one. There was Combine and Async in a way, where he was using Combine so that at the time that you're basically, as I kind of mentioned, like, when you're typing in that search text and you're trying to like filter on the fly and show other results, it's really nice and handy to use Combine. So that's what he was showing. And then we were using the async and await when we were making the network call. We're going to see another example where he's kind of, again, going to go and show how these two things can work together. I think I might have missed, was there stuff on chat that I missed? Okay, yeah, you just put here main actor. Nilakesh, am I saying your name right? Or do you have a short name?
Yes, you can call me name, it's fine.
Okay. Any questions that you have, since
No, this is awesome. So
yeah. It's really cool. Obviously there's there's a little bit of time that it takes to understand the new syntax and usage, but you can see how much clearer and nicer the code can be if we actually use this to how it was before. So so it's kind of worth
main actor is also a bit risky. So they have also made actors. So actors is again a type which is on the level of struct and class. So if we use actor, so actor is a single thread. So actor actually takes care of background thread, and then we have sendable, non-sendable, a lot of things in async await is very cool. I really like async await with SwiftUI.
Yeah. I think Apple did a really, and you kind of want to trust Apple to do this. There could be third party doing this, but it's actually kind of a non-trivial thing to do this whole suspension and be able to manage a whole thread pool, run this call, and then get the results, pop you back to where you were. So it's a lot of work that's happening in the background that you just don't see as you know, the person writing the code. It just works.
True.
Yeah.
True.
Okay, then I guess we'll see each other next Friday. I hope you guys are showing up for this great event. I'll probably broadcast the Navati for the Women in Code and the other one too, and have them invite you there, so we can get some more people joining.
Thank you so much. Yeah, appreciate this, and thank you folks for joining us as well. Yeah, we're so close to the end of this book, but yeah, it's amazing.
So another one to start, yeah.
Yeah, so sign up for both these sessions and more. The link is shared on chat. Yeah, you can reach out to me if you have any other questions. But yeah, thank you so much. Have a great weekend.
Yeah, you too, and take good care. Bye.
Take care. Bye.
Well, thank you.